Good morning. So my name is Carolina. The work I'm presenting now is one of the applications of the visual system that we are being developing for some years in Brazil. So we are now, this paper now presents the application with MIG welding, the short circuit derivatives. So vision is for us humans being the most used sense. Yes, we use the vision to do everything in our lives. Our capacity to process data, visual data, and capture this data is what have led to the developers to try to create devices that has some of our capacity. So our vision is basically inspiration for many technological devices. In welding specifically, the vision can give many information. These are some photos that I took in Fabtech 2011. Sorry, I haven't took yesterday, but if you go down there, you see many devices that has vision in welding specifically. So in welding, the vision can bring many information. The welder uses the vision to control the parameters, see how the weld pool is behaving, and a specialist can give information about the quality of the welded joint just by vision, and many other things like joint tracking and etc. So welding vision gives many different information. But the real question is how we can see our welding, our interest area, that is the joint and the surroundings, without the arc light interference. Yes, we all know that the arc light is the biggest barrier in visualization of the process. So one technique that is being said many times, I think a previous words used something like this, but what you do, you illuminate your area with a light in a specific spectrum that the arc light is low, and you filter in the same specific wavelength to have the arc light overshadowed, I don't know, by the laser or your illumination source. It doesn't have to be a laser by itself. Okay, just put it. Laser is one of the forms of illumination systems. We developed it from 2009 to now a prototype we call ViaSolda. It's a joke by See the Weld in Portuguese. But it's a welding vision system that we use high-power laser diodes to illuminate the interest area and in the spectrum of 905 nanometers. It's near infrared. And we use a low shutter camera, an analog camera that it's very low cost, about $100. And we synchronize the pulses of these lasers, diodes, with the shutter time of the camera to give us the visualization of the welding. So it's 30 frames per second. It's the low speed camera. These are the first results we took with this prototype. Is MIG welding, TIG welding, and globular transfer. These results are very promising, so we think that we can expand the use of ViaSolda, of our vision system, to another process. Our vision system is one of the technologies that are a response to industry demands for technology improvement. So another solution is a commercial solution are the development of new processes like derivative short-circuit MIG welding. They want increasing the quality and increasing the productivity. So the derivative short-circuit GMAW are defined by the electronic control of current. So they can adjust the waveform in response of the process oscillations. These derivative short circuits are created to join the advantages of conventional short circuit and attenuate some of its limitations like its pattern generation or regularity in metal transfer. I think the three most common commercial process in derivatives or short circuit are CMT, RMD, and SCT, each from one of the manufacturers. So it's the three of them works similarly. When the drop touches the pool, the melted pool, the power source controls the increasing of the current to make the drop grow more smoothly, and when the drop touches the melted pool, it controls the decreasing to make us more smooth also transference, increasing the influence of tensile surface and decreasing a little the influence of electromagnetic force. So the objectives of my work specifically are assess my vision system, the prototype that we built, with this commercial controlled short circuit MIG welding, SCT, CMT, and RMD. And focus what we can see in the pool behavior in the surroundings, and hopefully give us a better understanding of this process. So this is the parameters that we used. It was developed to have the same height deposition by welding length. Sorry, this was developed by my colleague, and we just used these parameters. So this is the gas, the shooting gas, and current, and the other specific parameters for each process. This is a schematic of our experimental site. We put the driver with the 19 laser diodes on one side, and the camera in the other side of the torch. You use similar distance and angles to make the directly reflected light. There are some of the equipment we use, and this is a photo of the real site. I just want to say that it cannot be seen by that, but the camera has a remote head, so it's very small. You can, and these are a future goal of us to put in moving with the torch like this. But in this setup, the torch is still, and the plate is moving. So before I present the video itself, the results itself, I want to note that the goal of my study is not to compare the derivative short circuit process. I don't want anybody from Helicon or from Miller getting mad at me, okay? The goal of our work is to assess what the vision system can give us with this process, what we can see what we can learn from visualization of the surrounding area of pool without dark interference. This table gives the medium current and voltage of each process.